Hey guys, we're looking at lesson 1 here of our new chapter. This is on integers and absolute value. So we're looking at ultimately what happens when you add, subtract, multiply, and divide integers. And we got some vocabulary. Some may look familiar, some may be a little new. We've got integer, negative integer, positive integer, graph, and absolute value. So let's take a look here. Okay, first thing we're going to look at, numbers like 5 and -8 are called integers. And an integer is any number from the set, as you can see, -3, -2, -1, 0, 1, 2, 3, 4, where the little dot, dot, dot means continues without end. So it actually goes in both directions. So let's look at a little graphic organizer here for this word integer. All right, so we want to describe what an integer is. Well, they just told us it's a number from that set right up above. But what did we see in that set? Well, we saw positive numbers. We saw negative numbers or 0. It was basically anything that kind of fell into that range. A positive number, a negative number, is 0. And they all, I don't know if you noticed, look at the picture over there. Those are all like whole numbers. Now, we're not really looking at fractions. We're not really looking at decimals. Those are going to be more when we talk about rational numbers. All right, so integers are more full whole numbers, which is kind of nice. All right, some examples, well, like we said, like a -4. How about -52? How about 0? How about 1,732,651? Integers. All of them are integers. All right. And what are some non-examples? Well, non-example, like we said, we don't see any fractions. We don't see any decimals. And we certainly haven't seen any percents falling into this category of integers. So those are things we're not necessarily going to deal with in this particular chapter. So where do we see it? The bottom of a snowboarding half pipe is 5 meters below the top. We're going to circle the integer you would use to represent this position. Would you say the bottom is at 5 or is it at -5? Well, since it's below the top, if we're going to describe it using an integer, we would say it's at -5. It's 5 meters below. All right, 5 meters below. All right. Well, can we think of another situation that uses negative integers? Well, one that always pops into my mind is temperature. All right, especially as we get into the winter months here. We can look at the weather report in the morning and say that the temperature is going to be -5 degrees Fahrenheit. That means that it's 5 degrees below 0 or cold, real cold. So the first thing we're going to do is we're going to identify integers and then we're going to graph them. We're going to actually put them on a number line. All right, and it's kind of crazy to think, but when you first learned about numbers, you learned numbers started at 0 and went all the way to infinity. Well, the funny thing is that was only half the actual numbers that existed. All right. 0 is not the starting point for numbers. 0 is actually the midpoint. Because if you go the opposite direction from 0, you're going to run into an infinite number of negative integers. All right, which we have as our first word right here. These are integers less than 0. And you use a negative sign to note that they are less than 0, or they are to the left of 0 on the number line. And the opposite of that would be positive integers. And positive integers are greater than 0. They are what you commonly thought as just regular old numbers. All right. Now, they can be written with a plus sign, but we generally don't, since we recognize those as our common numbers that we've learned from the first time we learned how to count. Just a regular number with no sign attached to it is assumed to be positive. And then our last type of integer is one that is neither negative nor positive, and that's 0. So 0 is kind of its own unique case. So integers can be graphed on a number line. To graph an integer on the number line, we're going to draw a dot on the line at its location. That is exactly as simple as it sounds. You may say, well, that sounds ridiculously simple. Well, it is. So let's look at a couple of examples here. Our first example, we're going to write an integer for each situation. All right. Number 1 says an average temperature of 5 degrees below normal. All right. Well, if it's 5 degrees below the normal temperature, anytime it's below, we think of it as being a negative. So we would say that would be -5 would represent that number. All right. How about an average rainfall of 5 inches above normal? Well, if it's above, we think of it as being higher, and our higher numbers are our positive numbers. So 5 in this case would be our integer we would use to represent this situation. So I said we were going to graph them as well. Well, let's look at this example here. It says graph the set of integers 4, -6, and 0. All right. So all you are literally going to do is draw a number line, then you're going to draw a dot at the location of each integer. So we've already drawn the number line. All we have to do is find the integer. So the first one is 4. Well, there's 4 right there. Look, I just graphed 4 on a number line. It's that simple. 0 right there, and -6 right there. There's no trick to graphing integers. When they ask you to graph something, you just draw a number line and you put the number right on the line. Absolute value. So this may be the one concept that's kind of new, but you should recognize the term at least. So what is absolute value? Absolute value of a number is its distance to 0. All right. So think about absolute value as being like distance traveled. All right. The example I always like to make is when we think about from here, this school, to like Harrisburg, all right? When we think about that distance, how far is that? Well, it's about 35 miles from here to Harrisburg, okay? So that means if you drive from here to Harrisburg, it's 35 miles. Well, by the same accord, if you drive from Harrisburg to here, still 35 miles. At no point are we traveling -35 miles. So that's exactly why you see in this example here that the absolute value of -5 is +5, and the absolute value of 5 is also 5, because we can see on the number line, -5 is 1, 2, 3, 4, 5 units away from 0. All right, well, +5 is still 1, 2, 3, 4, 5 units away from 0. So that's all we're concerned with when we look at absolute value. How many units away from 0 are we? And we always measure it as being positive. So on the number line in the key constant box, notice that -5 and 5 are each 5 units away from 0, even though they are on opposite sides of 0. Numbers that are the same distance from 0 on a number line have the same absolute value. So what we're going to do down here is we're going to evaluate each one of these expressions, all right, and we're going to look at how that's represented on the number line. So the absolute value of -4, that's what these straight bars mean on either side. They are what we call absolute value bars. So that is asking us, what is the absolute value of -4? Well, we look at -4 on this number line here, and we simply want to note how many units from 0 is it? 1, 2, 3, 4 units from 0. So the absolute value of -4 is 4. So let's put that into an actual problem here. So what if we had the absolute value of -5 minus the absolute value of 2? Well, one thing to note here is this little sticky note on orders of operations. It says the absolute value bars are considered to be a grouping symbol. So a grouping symbol is like parentheses. And when we look at order of operations, you always do the work in parentheses first. So if we have absolute value bars, we treat it the same way. And we're going to do the work in the absolute value bars first. So the absolute value of -5 is +5. It is 5 units away from 0. And then we're subtracting it from the absolute value of -2, or excuse me, +2. And the absolute value of +2 is also 2, because 2 is 2 units away from 0. The direction doesn't matter. So that simplifies down to 5 minus 2. Well, 5 minus 2 gives us 3. So we have a final answer of the absolute value of -5 minus the absolute value of 2 is equal to 3. So what do we do with absolute value? Well, let's look at this example, because I think this is a pretty nice way of explaining why you would want to know absolute value, what it means to you. So it says Nick climbs 30 feet up a rock wall and then climbs 22 feet down to a landing area. The number of feet Nick climbs can be represented using the expression the absolute value of 30 plus the absolute value of negative 22. How many feet does Nick climb? So the key to this is that last statement. How many feet does Nick climb? It does not ask how high has Nick climbed. All right, we just want to know the total number of feet that Nick has climbed. The direction is irrelevant to us. Where he is located is irrelevant. So in this case, we are interested in the absolute value of each one of those climbing sessions. So when he went up, he went positive 30 feet. So that means he climbed 30 feet. When he went down, which we represent with that negative 22, he's still technically climbing. He's just climbing the direction down. So really that negative is really just denoting our direction. So what's the absolute value of negative 22? Well, it's still 22 units away from 0. So if we want to know how many feet he climbed in total, well, he climbed 30 feet, then he climbed 22 feet, and that gave us a total of 52 feet. So we can use that absolute value to help us determine the total number of feet. If we were asking about how high he was, that would be a different question entirely, and not something we'd want to use absolute value for. So next up is your guided practice. You guys have 1, 2, 3, 4, 5, 6, 7, 8 whole problems, but I have a feeling you guys are going to get through these pretty quickly. All right, let's do those. Excuse me. Let's do those. We'll talk about them tomorrow, and we'll take it from there. Thanks, guys.